Hello everyone, my name is Kishan Agarwal. Today I'm going to present my concept video of analog and digital electronics, and my topic is comparison between combinational and sequential circuits. In digital logic, circuits can be classified into combinational and sequential. A combinational circuit or logic circuit is one whose output solely depends on its current inputs. Sequential circuits, on the other hand, are built using combinational circuits and memory elements called flip-flops. These circuits generate output that depends on the current and previous states. A digital logic or switching circuit has voltage levels to be switched from one value to another but has a finite number of distinct values, generally 0 for false and 1 for true. These circuits operate to definite set of logic rules, so it is also known as logic circuits. These basic these are basic circuits that are used in mobile phones, calculators, computers, etc. So today we are going to discuss what is combinational circuit and what is sequential circuit, how to draw a sequential circuit, and at the last we are going to see the comparison between combinational and sequential circuits. So first of all, what is a combinational circuit? A combinational circuit consists of logic gates whose outputs at any time are determined directly from the present combinations of inputs without regards to previous input. Example of combinational circuits are adder, subtractor, converter, and encoder and decoder. These circuits are developed using AND, OR, NOT, NAND, and NOR logic gates. These logic gates are building blocks of combinational circuits. The combinational circuit consists of input variable and output variable. Since these circuits are not dependent upon previous input to generate any output, so are called combinational logic circuits. A combinational circuit can have an n number of inputs and m number of outputs. In combinational circuits, the output at any time is a direct function of applied external inputs. So let us see the construction of combinational circuits. There are mainly 4 steps to construct and analyze any combinational circuit. So what is our first step? First step is to identify the number of inputs and number of outputs of the given circuit or the circuit which we want to draw. So first of all, we have to think about the inputs and outputs of the circuit by considering which type of logical operation we want to perform with the circuit. For example, if we want to create a circuit that can add 2 bits, for this we require 2 inputs. One for the first bit, let us say it has a and the other one for the second bit, which let us say it has a B, and 2 outputs, one for sum, that is S, of 2 bits, and another for the carry, that is C. So here we require 2 inputs and 2 outputs, that is 2 inputs are A and B, 2 outputs are sum and carry, S and C. So here our first step is complete, that is to identify the number of inputs and outputs of the circuit. Next, second step is creating the truth table. After identifying the input output, we have to write the truth table. In this step, we have to create truth table for our circuit. So for these, first we will create input column and list all the possible combinations of inputs. In a case 2, bits can have maximum of 4 combination: 0 0, 0 1, 1 0, and 1 1. Since here the input is 2, we have 4 combinations. Now in output we have 2 columns, that is sum and carry. As we have discussed, like After giving inputs, we need to add these two numbers. So we add, we get sum and carry. So we are denoting it with S and C. Now we have to fill output columns in such a way that for which logical operation we are constructing circuit. So in our circuit we want addition, so we will add those two input bits and write the sum of those bits in sum column, and if carry is generated we'll write 1, else we'll write 0 in the carry column. So here we see when both a and b are 0, sum and carry value becomes 0. If a is 0 and b is 1, sum will be 0 and carry will be 0. At the same time, when a equals to 1, b equals to 0, sum will remain 1 but carry will also remain 0. In the case of a equals to 1, b equals to 1, sum will become 0 and carry will become 1. How? 1 plus 1 is 1, 0. So 1 is our carry and 0 is our sum. Moving towards the step 3. Step 3 is to simplify. That is, simplify the Boolean algebraic function for each output. In this step, we have to just create a simplified Boolean function according to inputs and outputs of the truth table obtained in the previous step, that is step 2. For sum, we get sum is equals to, see here, sum values are 1 in two cases, that is a dash b and a b dash. So we are going to add both a dash b and a b dash. We know that a dash b plus a b dash is equals to a exclusive or b. For carry, we have only one value, that is ab, that is a and b. So this is how simple to construct an algebraic function. Now our step 4, which is the last step, is to construct circuit. Constructing circuit using Boolean function obtained from the third step. For sum, we have obtained a exclusive or b, so we will construct a and b to the inputs of XOR gate, that is exclusive OR gate, and takes it output as a sum. For carry, we have obtained a and b, so we will connect a and b to inputs of AND gate and take its output to as carry. Finally, half adder is constructed. Now in this circuit, if we provide input value at a and b ends, you will get the output on the sum and carry ends according to the truth table we have created above. So here we have completed our fourth step to construct combinational circuits. Next is our sequential circuits. A sequential circuit is specified by time sequences of input, output, and internal states. The output of a sequential circuit depends not only on the combination of present input but also on the previous outputs. Unlike combinational circuits, sequential circuits include memory elements with combinational circuits. Some of the examples are counter and shift register. So we can just say that sequential circuit is a combinational logic circuit that consists of input variable logic gates, that is computational circuit, and output variable Z. A combinational circuit produces an output based on the input variables, but a sequential circuit produces an output based on current input and previous output variable. That means sequential circuit include memory elements that are capable of storing binary information. That binary information defines the state of sequential circuits at that time. A large cable of storing one bit of information is attached to the combinational circuit Thus we obtain a sequential circuit. This is a simple block diagram of sequential circuit, which consists of a combinational circuit with a memory element connected to it. So, as shown in the figure, there are two types of input to the combinational logic. One is external input, which are not controlled by the circuit, and the other is internal inputs, which are function of previous output state. Secondary inputs are state variable produced by the storage element, whereas secondary outputs are excitations for the storage elements. So here the memory elements are circuits capable of storing binary information. The binary information stored in these memory elements at any given time defines the state of the sequential circuit at that time. The external output of a given sequential circuit depends both on the present input and the previous output state. The next state of the memory elements also depends on the external input and present output state and external output. Some sequential circuit may not contain combinational circuit but only memory element. So generally there are two types of sequential circuits are there, which is type 1 and type 2 sequential circuits. So type 1 is asynchronous sequential circuit. These circuits do not use a clock signal but uses the pulses of the inputs. These circuits are faster than synchronous sequential circuit because there is a clock pulse and change their state immediately. When there is a change in the input signal, we use asynchronous sequential circuits when speed of operation is important and independent of internal clock pulse. But these circuits are more difficult to design and their output is uncertain. This is how a asynchronous sequential circuit look like. Our next is type 2 sequential circuit, which is synchronous sequential circuit. This circuit uses clock signals and level inputs, or we can call it as pulsed inputs, with restrictions on pulses width and circuit propagation. The output pulse is the same duration as the clock pulse for the clocked sequential circuit, since they wait for the next clock pulse to arrive to perform the next operation. So these circuits are a bit slower compared to asynchronous. Level output changes state at the start of the input pulse and remains in that until the next input or clock pulse is given. So this is a synchronous sequential circuit which is connected to clock pulses. We use synchronous sequential circuit in synchronous counters like flip-flops and in the design of Moremili state management machine. Generally, there are two types of storage elements used in sequential circuit. They are latches and flip-flops. Storage elements that operate with signal level rather than signal transmission are referred to as latches, and those are controlled by clock transmissions are flip-flops. So we can say that in a synchronous type of sequential circuit we use latches rather, because there it operates without signal levels, and in the second type, that is synchronous sequential type of circuits, we use flip-flops as a memory storage. Next we'll see the differences between combinational circuit and our sequential circuit. So combinational circuit, let us see the definitions of combinational circuit and sequential circuit, which we have already seen. So as discussed, combinational circuit is at any instant of time the output is only dependent on the current state of inputs, whereas in sequential logic circuit at any instant of time the output is determined by both inputs and the previous outputs. Time dependency. Time is not important parameter in combinational circuit, but time is an important parameter for timing and synchronizing of different circuits elements. A clock signal is necessary in sequential circuits. Memory. No memory is required. That is, the output is solely dependent on only input only. So there is no memory required for combinational logic circuits, whereas memory is required to store the previous outputs generated in the sequential circuit. Design. The combinational circuits are easy to design and implement with the help of basic logic gates, whereas the design of these systems require basic logic gates and even flip-flop and latches to store the memory. As for the memory purpose, feedback. There is no feedback, but there is at least one memory feedback element in the feedback path in sequential circuits. Hardware and cost. Combinational circuits are easier to implement but costly due to the hardware. Their implementation requires more hardware compared to sequential logic circuit. They are difficult to implement but less costly than sequential circuit. Next is speed. They are faster since all inputs are applied at the same time, but sequential circuits are slower because of the secondary inputs. So there is a delay in between inputs and outputs by the clock signal. This was few differences between combinational circuit and logical circuits, sequential circuits. Thank you.